who's coming to us from ENAF and IPDA, and he's the archive manager for an instrument on the Dawn mission, and also ExoMars instruments, and he's a member of the IPDA Technical Expert Group, and will talk to us today about the IPDA, the International Planetary Data Alliance. So, Marco, please, I'll give you a couple of minutes before the...
Yeah, thank you. Hello, my name is Marco Giardino from ENAF. I'll talk to you about the IPDA organization and its definition and its current activity, and try to give an overview. The IPDA is a pretty young organization. In 2005, it was recognized that the international agency should collaborate and in coordinating standard and sharing the planetary science data coming from a planetary science mission. And so this led to the formation of this organization in 2006. The mission of the IPDA is stated in this sentence. It's basically is to facilitate the global access to the data, which is public funded, and the exchange of this data, and to the production of a high quality scientific data product, and this done across international boundaries, and trying to try to resolve any burden between these international boundaries. So how is done this? The idea is through two main methods: is to support construction of compatible archives, and also to support sharing of tools and software services. We can say we can look at this like more or less three layer, which is the data layer, which is the compatible archive, which means archive that can have a similar format or compatible format. Then a second layer when we talk about services, which are on top of that archive and which can abstract from difference between different formats in the archives. And a third layer, which is the tools, which are the layer composed by different tools, which can use different services. So abstract again the difference between services across the world, and manage the different data source into a single point of access to the service or a tool function. The IPDA data access is based primarily on a single model, which is designated by the PDS4, which is the recent standard, which is still under implementation, which is the evolution of the PDS3, which was used by with the former standard definition used in the previous mission, planetary mission. And now there is a huge effort on PDS4 by both NASA and engineering node at PS, and also this process involves other agency, and the IPDA is strongly involved in into this process by both definition and by also gathering the feedback from scientific teams and instrument teams and users. So the idea behind PDS4 is to create a standard which has the much possible wider community, and the maximum interoperability between also the different instruments and different data sets produced by planetary mission. Okay. In 2008, as an achievement, IPDA was recognized by the COSPAR, which is the Committee on Space Research. The Commission B passed the resolution identifying an important role for IPDA, which is the developing the standards for international interoperability. So this is an important achievement. This is the exact sentence coming out from this event in the 2010. The structure of the EPDA is essentially the EPDA has 2 members for each agency involved in this organization. Current membership is open, and here is the contact for affiliate the agency. And the current membership, just to go forward, this is the membership currently involved in the IPDA. I go forward, so just to give a quick overview. And the structure of the organization is composed by 3 main components, which is the steering committee, where 2 members from each agency are appointed and compose the steering committee, which is basically the entity making decision about the projects and the pathway to the next step for the IPDA. Then the technical expert group, which is again composed by members from agency which are appointed, and the one implementing the projects defined by the steering committee. And so the core projects, which are really the projects defined and developed during the lifetime of the organization. I go through a quick overview of the core projects currently defined. These are we will see very quickly each of them. So we start with the PDS4 implementation, as said before. This is the new international standard, which is the goal of the PDS4 is to capture recommendation requirements based on preparation and implementation of PDS4 by authorities and institutions also outside NASA. So as said before, this is a strong effort to involve the wider possible community outside also NASA to reach this goal. These are the current mission involved in producing datasets using already the PDS4 mission, and these are just a quick look of this mission, and more to come in the future. Then another core project is the registration and search, which is to deploy and search and try to develop a search infrastructure which capable of allow multi-agency search for planetary data. During the PDS4 and as a parallel project, the PDS4 project, registration and tool infrastructure is currently deployed at the PDS engineering node at NASA. This is a schema representing the feature of this service. Here, just to trying to show which is the real advantage of multi-agency search. As you can see on the left, we have the PSA, which is the Planetary Science Archive at ESA. To the right, we have the discipline nodes of PDS related to NASA activities. And so, through this kind of registration and search service, it is possible to register different datasets to different registry, and then integrating these 2 registry through the use of targeted protocols, which is PDAP for the ESA side, or PDS or other international archives, and PDS registry interface for PDS discipline nodes. It is possible to have in a single point or single access point, which is, for example, the PDS PDS node, to perform single query searching for a particular target or a particular instrument category, and as a result, this is taken directly from a query result. This is an example. By looking for Venus Express, you see to the left that in the what's come out from this search. It's both the two format PDS4 and PDS3 legacy. But the important thing is that both the agency, the ESA and the NASA, are coming out from this result. And so from this link you can directly access the web-based interface from the related agency to to which the dataset belong. And another project regards the third layer I said before, which is the tool layer, which is a sort of repository for all the tool which can be useful for planetary science community. So the aim of this project is to sort of list and evaluate and validate this list of tools, and also to encourage the sharing of international sharing of tools related to the planetary science activity. For example, these are some examples from tool included inside this registry, which is geometry, for example, geometry library, or PDS package for IDL programming, and this sort of tools. Another issue regarding the interoperability, which affects the planetary datasets in general, is the geometry issues. So the localization of the remote sensing dataset. This is not all the instrument and all the mission have the same approach to geometry information. And so the goal of this project is to try to support the interoperability and the standardization of geometry information included inside the exposed scientific data. For example, the PDS4 in this sense will represent a big step forward, because a lot of this geometry information will be standardized and will be included as a common layer into the dataset for planetary science. I will not make long speech about this project. It's a Chandrayaan-1 interoperability with PDAP. PDAP is a protocol defined by IPDA, which is a data access protocol used for, as you said before, as you have seen before for the registry search. It's a protocol allowing the interoperability between different archives by making transparent the difference between archive, and allowing the query between these different archives, and the possibility to integrate into a single query different formats, and hiding the information difference between the format difference between the different archives. This project here is also involves the necessity and the needs to access also the legacy PDS3 data by using the PDS4 registry. As you've seen before, this is also a real possibility, because it's currently implemented, for example, in the PDS node.
Marco, just a few minutes.
2 minutes, okay. This is the protocol, the PDAP protocol I speaking before. So the idea behind this is to implement, and this is currently implemented version 1, but is still in development, because as you may imagine, this is a development for the increasing needs for different datasets. So the Planetary Data Access Standard Protocol is idea to have a common protocol, a data access protocol, for access to the metadata of data sets exposed by planetary missions. Finally, another key project is the creation of Memorandum of Understanding template for international mission. The goal here is to propose a reference MOU for officials. As you may already know what is a Memorandum of Understanding, and the idea is that all the scientific data obtained by International Planetary Mission should be open and shared widely as a human intellectual assets. So these are some key points about this template for this kind of documents. There are I have some less short time, so I go faster. And the idea is in the Memorandum of Understanding, the key question to be answered are about the creation of the data. So we'll see what the data will be, who will produce the data, where the data will be produced. So it means which agency, when, so how long the preservation of the data and when will be the data available, why, so which will be the purpose of for the use of the data, and how the data will be produced, and for which will be the budget for the data access and for the data preservation. So these are the key questions to be answered during the definition of such sort of documents. Finally, also as you have already seen this morning, the IVOA is a similar organization in some sort, and so we have a key project exploring the interaction between these two organizations by trying to reinforce the interoperability between these two infrastructures, because the missions are very similar in some key aspects. So we have a key project related to these interactions. This is a list of argument, list of issue related to this interaction. Finally, just as a final remark, we just want to stress the current involvement of ASI in planetary mission, and besides this telling which are this mission, we want to stress the fact that during the operating phase of this mission, these data are all archived in the science archive of the agency, but what is asked formally by ASI to all these data providers is to build PDS compliant datasets and deliver them as agreed in the data management plans defined at the start of each project, of each mission. Thank you. That's all.
Okay, thank you, Marco. Are there some questions? Andy Pollock has a question.
Can you say what drove the evolution from PDS3 to PDS4?
PDS3 is just a little longer. It's a standard which has been around for a long time and was defined with when the technology was a bit long time ago. So in science, in information theory, the things have changed a lot, and so PDS4 has also taken this opportunity to keep forward, to try to improve some of the issues that were emerged during the PDS3 definition and during some of the main problems by using PDS3 datasets. To address some of these issues, I can tell you that the information model was not so wide in its definition, and so a huge improvement has been made about this, to trying to make it a lot wider, a lot general, more general, to include different data sets. Then we can say about the use of the XML, which is from the software engineering point of view, is also a big step forward, which allow just to say the possibility to validate the dataset and to validate the data production in a very better way than with PDS3, which suffered with a lot of problems during the validation of the data, and so this was solved by PDS4. Then I think also to be much appreciated the involvement, the general involvement, international involvement in the definition of the PDS4, which probably was not so general for PDS3. So now this will result in a better generalization of the standard and the possibility to interoperate different archives from different agencies, seeing that these agencies are already involved in the definition phase and implementation phase of the PDS4, which is not a complete standard, which in evolution phase. So during the year the version is incremented, and the feedback from the international scientific community of planetary science is taken in consideration, and the standard is evolving with this feedback, which is fundamental because it's a user feedback. So when I think when a standard is defined with a user in mind, it's much better. Okay.
Okay, so I think we'll finish off with by thanking all of the speakers once again. And I think Paolo will want to get on with the
no, not really me.
part of the session,
the next thing on.
I don't know who's in charge now.
I think we have a little small discussion.
We're about 20 minutes late, and we need to start the discussion. And there are some moderators. I know that Massimo De Angelis wants to show a couple of slides, so he's just trying to load them on the machine.